Good evening, everybody. It's Professor Brown, and I'm going to go over the Planetary Climate Lab with you guys. So let me pull it up right here. Okay. What I like about this lab relates to us here on Earth, and it kind of takes global warming, and we really just going to apply it to some of the other planets in our solar system. So first thing you want to do is definitely read through the background. Make sure you know the definitions to all the highlighted words here. Greenhouse gases, carbon dioxide, because they're going to reappear later on in the lab within questions, and you should definitely be using them for some of your answers. Okay. Basically, what we're looking at in this lab is how do planets heat up and how do they cool down, right? During the day, why is the Earth heating up? At night, why does it cool down? And it's a very simple explanation, as you can see in figure 13.1 here, right? The Earth is going to absorb visible light from the sun. And at night, night's going to be on this side, right? We're going to radiate infrared energy. Hopefully you can see that how I spelled it. Okay, so we're absorbing visible light. We radiate infrared, and if we're in thermal equilibrium, that means there should be some type of balance, right? We know in the wintertime we have shorter days, longer nights, so we're radiating more energy than we're absorbing, so therefore temperatures are cooler. But overall throughout the year, we're in radiative balance because in the summertime, it's basically the opposite, right? We have longer days and shorter nights, so we're absorbing more and radiating less. Okay. What we want to throw in here, though, are the greenhouse gases. Now, we should all know that, one greenhouse gas is carbon dioxide, but there are actually two others. See if you get on the internet and figure out what those two other gases are. Okay, so the first part of this lab, definitely don't forget to do question number 1 up here, is basically graphing and comparing. Okay, so the first thing we want to graph here is the calculated equilibrium temperature from table 13.1, which is this column here, to the distance from the sun for each of those 4 planets, which is that column there. Okay, when we take a look at our graph here, we have temperature on our Y in red, and on the X, we have our distance from the sun in AU. Okay, make sure you're using a filled-in circle on the spot of your graph, and you label the marks. Okay, I'm figuring that they want you to label the name of the planets for each mark that you make. All right. After you graph that, we're going to do some comparison. And then number 4 and number 5, make sure you don't forget to do that. Okay, you're going to add the minimum observed temperature from figure 13.2. So I'll highlight that one in blue, right? So this is the blue one. And then in green here, we're going to add the maximum temperature on a small horizontal line, which is this here. Okay, and then we want to see where does everything fall in comparison. Okay, and then basically you go through each question, and then we get to step 3. Okay, now step 3, you definitely should be going back into the reading for some of these. Okay, absorption versus emission. Absorption just means to take in. If you emit, you're going to give off. Okay. When we're absorbing stuff, we should be heating. If we're emitting, we should be cooling. Okay. And some very basic questions here. A lot of these questions are very practical to day-to-day life. For example, number 15, when visible light strikes a dark surface, it is absorbed and the object heats up. State one example of an observation you may have made that demonstrates that this is true. I mean, there's plenty of examples that I'm off the top of my head that I can think of. So go through each one, answer them. If you come to any obstacles there, feel free to email me. All right. And then we're going to look at numbers versus percentages here. Okay. Again, for step 4, some of these questions you might be required to go back into that background. For example, number 1, astronomers put infrared telescopes in space. Why is that? All right. And that's going to be back in the background information. Okay. And then we just kind of go through here. And basically we're just answering questions, looking at graphs. Really nothing tricky here. All right. And then we go here, step 5, and we kind of just put everything together. Okay. Again, what's nice about this lab is that, a lot of it does relate to us here back on Earth with the global warming, climate change, and the greenhouse effect. So we're just kind of applying it to the other planets in our solar system that have a different atmospheric composition than our own. All right. If you have any questions on this lab, feel free to email me, and good luck.